Welcome to our physics class. We will discuss today about the particle velocity, wave velocity, and the relation between the wave velocity and phase velocity. Now, what does it mean by the particle velocity? You know, uh, we can represent the position of a particle with this equation: y equal to a sine 2 pi by lambda vt minus x. Here v means wave velocity. Wave velocity. Suppose wave velocity. V is the wave velocity, and where x is the position of any particle. If you desire a particle, suppose this is a particle. Okay. Now the position of this particle, like this. This is the position. The particle vibrates up and down. Okay. This vibration. Okay. This particle, the distance between this particle and the shores where the wave created, where the wave begins to run, where the waves created from this position to this position, or this is the first particle of the wave. This is the first particle of the wave, and this is our desired particle. And the distance between these 2 points, the first particle and this particle, this is the distance x. Okay. Now if this position equation, this is the equation of particle, this is the position equation of a particle in a wave. Then if it is given to your question and asks to you what is the velocity, then you have to differentiate this equation to get the velocity, to get the particle velocity. This equation for the position of a particle. Then if you differentiate this equation with respect to time, then you will get particle velocity. Suppose dy by dt. This velocity is particle velocity, but this velocity is phase velocity or wave velocity. This is phase velocity or wave velocity, but this velocity is particle velocity. You differentiate y is the position of a particle, then dy by dt, this is the velocity of the particle. Here a wave moves towards, but the particle moves up and down or to and fro, in a wave, but the wave moves forward. The waves spread out. The wave moves forward, but the particle in a wave, suppose this is the wave. The wave moves forward, but particle moves up and down. This velocity is the here up and down. The particle moves up and down. Here the velocity of the particle and this velocity is here. This is wave velocity or phase velocity, and here v, this is particle velocity. This is particle here, the particle velocity is here, and the phase velocity or wave velocity here. Where the waves moves forward, there is a velocity. This is called phase velocity or wave velocity, and where the particle moves up and down, there the velocity is called particle velocity. Okay, differentiate this one. Uh, a sine cos 2 pi by lambda bpt minus x. Then again you have to into d by dt 2 pi by lambda bpt bpt, okay, minus x. You know, x is the position of a definite particle. So the distance from the first particle to the definite particle, this distance will be constant. So after differentiating constant, okay, into d by dt 2 pi by lambda bpt minus 2 pi by lambda x. This one after differentiating, this one will be 0. After differentiating this one, this will be 0. Now we can differentiate this one. So this will be 0, and now differentiating this one. After differentiating t dt divided 2 pi by lambda vp, this will be constant, and then differentiate dt by dt by dt. Yes, dt by dt. Then you will get only this one after this one. So so v equal to 2 pi vp lambda a cos 2 pi by lambda bpt minus x. 2 pi bpt a cos 2 pi by lambda bpt minus x. This is the required equation for the particle velocity. This is the required equation for the particle velocity. P means phase velocity, or this is also we can call wave velocity. Okay. Now what is phase velocity? We will discuss something elaborately about the phase velocity. Okay. This is a wave, and wave 1 lambda 2 lambda 1 lambda 2 lambda this lambda 1 lambda 2 lambda. Okay, and suppose time equal to 1 second. There is a total 2 lambda and time is 1 second. 2 lambda, this is a distance covered by the waves. 2 lambda for 1 second. In 1 second this wave covered 2 lambda distance, 2 lambda centimeter or 2 lambda meter distance covered by the wave in 1 second. So in 1 second the distance you got 2 lambda. So the velocity of this wave is 2 lambda meter per second. 2 lambda is a distance. Suppose 2 lambda equal to 10 centimeter, 2 lambda equal to 10 meters, suppose, then 10 meter per second. This is the velocity of the wave. And what is 2 lambda 2 2 is also called frequency. In 1 second there are 2 complete waves. In 1 second there are 2 complete waves. Therefore the frequency of the wave is 2. So the frequency 2 means n. We denote the frequency by n and lambda. Therefore v equal to n lambda. V equal to n lambda. V is the velocity of waves. Velocity. Velocity of waves, and or we can also this is also called phase velocity. Okay, now we can call by wave velocity. Then wave velocity equal to n lambda. V equal to n lambda. Wave velocity equal to n lambda. Now suppose you are given an equation y equal to a sine omega t minus kx. This is given to you. Y means position of a particle. A amplitude this is amplitude as sine omega t minus kx. Suppose this is a particle, this is any particle, and okay, let's consider this is a particle. This will be convenient to consider this particle for discussion. This one, okay, x is the distance of this particle from the first particle. This is the first particle, and this is any particle. You can decide any particle, Okay, the distance between the first particle and this particle is x. This one x, this particle. Okay. After few minutes, this crest, actually we choose the particle at the crest. After few minutes you will get another, the next crest. This is the next crest. This is the next crest. This is the first crest, Shishubindu. Then you will get the next crest, this one. After some times you will get the next crest, and next crest. Okay. So along to the time is moving, and with this moving time, the position of the crest, is changing. The position of the crest changing. Crest changing means the wave is moving. The wave is moving means the crest also moving. You will get the next crest. This is the first crest, Shishubindu, Pratham Shishubindu. This is the second crest, Dityo Shishubindu. With the time moving, you will get first crest and the second crest, and the x also changing. X is the is a distance of a definite particle. Suppose you choose the crest, the first crest. Okay, after some times the first crest, you will get the second crest. First crest, then the second crest, and first crest and the second crest. Then the distance x is also increasing. That means wave is moving. Therefore dx by dt, x is changing, x is increasing. Therefore there is a velocity. Dx by dt means the velocity. So this velocity should be the wave velocity, because crest moving, x moving, x changing means wave is moving to forward. X changing means dx by dt is the velocity. The velocity is actually the velocity is the wave velocity, because the wave is moving and x is moving. So dx by dt is the wave velocity, or it is also called phase velocity. Suppose the crest is a phase. Phase means this is a position. This is a definite position. Phase means avastha, condition. Crest means one of the condition, one of the position. This is a position. So this position changing, crest to crest, or turf, padabindu, turf to turf, crest to crest. This is the position, changing of the position. Position means phase. The changing of the position means phase changing. Phase changing means wave moving to forwards, and this velocity is called also phase velocity, or wave velocity. Now omega t minus kx, this is also called phase angle. This is called phase angle. This is the phase angle, and phase angle of a equation should be constant. The phase angle should be constant. This is a wave, and the pattern of this wave, the pattern is of this point is not changing. The pattern also not changing, but the wave moving up and down, there is changing, but the total pattern not changing. Suppose here the waves pattern changing, the pattern changed, the pattern changing. Here this wave, in this wave the wave pattern changing. If the wave pattern changing, then this phase should not be constant, but the pattern is not changing, then this phase angle should be constant. So d by dt omega t minus kx equal to 0. So this is the phase angle, omega t minus kx. This is the phase angle. This phase angle or phase angle or phase is constant. Then if you differentiate with respect to time, this will be 0. Because this is constant, the differentiation will be 0. You remember v equal to n lambda. V means wave velocity. V equal to n lambda. Wave velocity. Now differentiate this one, omega dt by dt minus k dx by dt equal to 0. K constant, omega constant, k constant. Okay, dt by dt, dx by dt. Now omega minus k dx by dt equal to 0. Then dx by dt equal to omega by k. This dx by dt is the phase velocity. This dx by dt is the phase velocity. Now omega equal to 2 pi n. Omega equal to 2 pi n. Omega means angular velocity. Equal to 2 pi n. 2 pi n. N is the frequency. And k equal to 2 pi by k equal to 2 pi by lambda. K equal to 2 pi by lambda. In our previous class, you will get k equal to 2 pi by lambda. In our previous class, you can get the relation of k equal to 2 pi by lambda. Okay, then 2 pi 2 pi, then you will get n lambda. So dx by dt equal to n lambda. Dx by dt is the phase velocity and n lambda is the wave velocity. Wave velocity. So therefore you can write phase velocity equal to wave velocity. Phase velocity equal to wave velocity. You can write this. This is the phase velocity equal to wave velocity. This is our required expression. Phase velocity equal to wave velocity. Now problem 7. Problem 7. A plane progressive wave is traveling in a gauge along the positive x-axis with amplitude equal to 2 cm, velocity 300 meter per second and frequency 400. Calculate the displacement and velocity of the particle at a distance 4 cm from the origin after an interval of 5 seconds. You will get this problem in our presentation slide. Now you can write the equation of progressive wave y equal to a sine 2 pi by lambda Vt minus x. Amplitude A is given 2 cm and v velocity equal to given 300 meter per second. Equal to 3 into 10 to the power 4 centimeter per second. 3 into 10 to the power 4 centimeter per second. X, position x equal to 4 centimeter and time t equal to 5 seconds. These are given, and also lambda equal to v by n equal to 3 into 10 to the power 4 divided by n and v and n and 400 and frequency also given, frequency 400. Frequency also given into the question, frequency 400. Then you will get 75 centimeter. These are given. Now y equal to s and 2 pi by lambda 3 into etho. So 2 means a means 2 sine 2 pi by 75, 3 into 10 to the power 4 into 5 minus v equal to 3 into 10 to the power 4, 3 equal to 5 second, and minus x equal to 4 and after calculating in your by using your calculator, just use your calculator, just put these values into your calculator, then you will get directly to the answer equal to minus 1.1756 centimeter, 1. Minus 1.1756 centimeter. Okay, now this is the one answer, is the one of the answer. Now the particle velocity v equal to dy by dt. Particle velocity, this is the position of a particle, then dy by dt is the particle velocity, not wave velocity. This is the particle velocity. 2 pi v by lambda into a cos 2 pi by lambda vt minus x. X. Okay. Similarly, put the values of v lambda a x. Put this value like the previous one. Put this value, and by using the into your calculator, then you will get directly the answer of velocity equal to 40.68 meter per second. Okay, this is the two results required by the question. Now we will discuss about the architectural acoustics. Acoustics means shabdo bigyan, sound. Acoustics, architectural acoustics, and the most important factor contributing to the acoustic badness of a building is excessive reverberation. Acoustics badness, shabdo, sound, bad sound, the noise. Acoustics badness means noise of a building. Noise of a building is the excessive reverberation. Reverberation means excessive echo. Reverberation means excessive echo, or reverberation means the prolonged reflection of sound from the walls, floor and ceiling of a room. Reverberation. Reverberation. Reverberation means the prolonged reflection. Prolonged, not very long or not very short. Not very long, not very short. This is the prolonged. The medium. Prolonged reflection. যথেষ্ট প্রায় অনেকক্ষণ ধরে, খুব বেশিক্ষণ ধরে না কিন্তু অনেকক্ষণ ধরে রিফ্লেকশন, প্রতিধ্বনি, প্রতিফলন, রিফ্লেকশন অফ সাউন্ড from the walls, floor, ceiling of a room. This is reverberation. And also you can define the reverberation like this. The persistence of a audible sound after the source has ceased to operate is referred to as an reverberation. The persistence of audible sound after the source has ceased. Source has ceased. যখন শব্দের উৎসটাকে বন্ধ করে দেওয়া হবে তখন অডিবল সাউন্ডটা যতক্ষণ ধরে শোনা যাবে, অডিবল সাউন্ডটাকে প্রতিফলনের কারণে ফর রিফ্লেকশন অফ দ্য সাউন্ড, প্রতিফলনের কারণে সাউন্ডটা যতক্ষণ শোনা যাবে, হ্যাঁ, পারসিস্টেন্স মিন্স যতক্ষণ শোনা যাবে, যতক্ষণ সাউন্ডটা শোনা যাবে, বারবার শোনা যাবে, এটাকে আমরা বলছি রিভারবেরেশন। You will see a table of absorption coefficient at 500 Hz. Acoustics properties to represent the acoustics properties of rooms or halls. These coefficients, absorption coefficients, are used to express the acoustics properties of a room or halls. Suppose if the window are open window, একটা রুমের জানলাগুলি যদি খোলা থাকে, then the energy there will be no energy reflected 0%. So উইন্ডো যদি খোলা থাকে তাহলে শব্দগুলি খোলা জানলা দিয়ে বের হয়ে যাবে, সেগুলি ফিরে আসবে না, রিফ্লেকশন হবে না, সো এগুলি বেরিয়ে যাবে, মানে অ্যাবজর্বড হয়ে যাবে। The energy, 100% energy, sound energy absorbed. So the absorption coefficient is 1. That means 100 by 100. 100 by 100 means 1. Now if the wall of a room is 1 centimeter, the wall and the wall of a room is 1 inch fiberglass. A room is made by 1 inch fiberglass. There energy reflection will be 20%. The sound energy will be reflected, the 20% sound energy will be reflected from the 1 inch fiberglass, and therefore 80% energy will be absorbed by the fiberglass, and the absorption coefficient will be 0.8. 0.8 means 80 by 100. Open window 100 absorption. Now fiberglass 80% absorption, and then the coefficient will be 80 by 100. Similarly, half inch gypsum board 96% reflected and only 4% absorbed, so the coefficient will be 4 by 100. 4 by 100 means 0.04. and 4-inch brick 98% reflected and energy absorbed only 2%. So the energy absorption 2 by 100 and 0.02%. 0.02 is the absorption coefficient and 2% energy absorbed and 98% energy reflected by the 4-inch brick. So you have to know the explanation of this absorption coefficient in this table. Now, what is the reverberation time? What is the reverberation time? The time of reverberation is defined as the time taken for the energy density to fall to the minimum audible value from an initial value. Stop here. Just reverberation time is defined as the time taken for the energy density to fall to the minimum audible value from an initial value. Reverberation time bolte বোঝাচ্ছে the time taken of the energy density একটা সাউন্ডের এনার্জিটা একটা মিনিমাম অডিবল ভ্যালুতে ইনিশিয়াল ভ্যালু থেকে একটা মিনিমাম অডিবল ভ্যালুতে এনার্জি ডেন্সিটিটা নেমে আসতে যে সময় লাগে সেই সময়টাকে আমরা বলছি রিভারবেরেশন টাইম অফ রিভারবেরেশন. This is the definition of reverberation time.